Let's look at the alkaline earths. So let's come along. We'll grab the known. This has now the barium, strontium, calcium, and magnesium plus 2, all of these. We need a strategy to separate these. Recall that the sulfates are one possibility. It turns out carbonates are another, and hydroxides are another. If we look at the KSP of barium and strontium sulfate, we find that they are much less soluble than calcium or magnesium, so we can pull them apart, barium being the least soluble. The other advantage we have is that with pH we can control the sulfate concentration through the Ka2 of sulfuric acid. So what we're going to do is acidify this, and we'll acidify, we'll check the pH, it's good in acid. Now we'll add the sulfate, and we get a precipitate, but notice that in the acidic conditions we have the barium selectively precipitated. We'll come up now, and now we're going to raise the pH to 4, and that's going to pull out the strontium. So we'll spin that one out, decant it, and we'll come up like this. So we've got barium and strontium, and so now we have the calcium and magnesium. The best way to do this is take advantage that the calcium hydroxide is more soluble than the magnesium hydroxide. So let's raise the pH up to 10. We now get the magnesium hydroxide to come out, and we'll check to see if we have calcium by adding now carbonate, and there's our calcium carbonate. And so we've got all of those separated. We can come back up and take an unknown. So if we came and got the unknown, we'll put that over here. We'll do the same kind of thing. We'll acidify it. We'll check it with the sulfate. There's our barium. We'll come off like this way, and we'll replace that. Now we'll raise the pH up. It's got strontium as well, and so we'll decant that. And there's a barium and strontium. There's our barium and strontium. Now we'll come up to 10 and look for the magnesium. There isn't any magnesium, and so now we'll add the carbonate. Doesn't look like there's any calcium as either, so I think we're okay.